Well, let's get started. Uh, Today, we'll go to a new chapter, move to a new topic that is generics and exceptions. It's a chapter about errors when we do programming. So it's very important because we all, when we make code, we will meet a lot of problems, not the errors, and we want to deal with these errors. And this chapter will give you a lot of basic tools that will help us to deal with errors inside of a code. Okay? Before we get into this chapter, we should know some basic idea about errors inside of a code. Generally, when we make code, two types of errors we will get. The first one is compare time error. That is, after you write a code, you use edit. For example, use NetBeans in the edit window, you write a code. Then, when you finish your code, you will compare tool inside NetBeans, or simply use the menu item, compare this item to compare your code, and maybe at this time you'll get errors. This error we name as compare time error, and this error basically is grammar related. For example, you declare a variable, but this variable, the type, you make a typo, for example. So it causes a compare time error, and the compiler will help us to get this error because it will check our code. It will scan from the top to bottom through all our code and find the compare time error for us. So, and it will mark the location of these errors inside either the window. So it's very simple for us to find them and correct them. This is compare time error. But another type of error is not so easy for us to find. That is the runtime error. The runtime error means when we finish comparing my code and we correct all of these compare time errors, and our code can be compared successfully, and then in Java we get the bytecode, and then run the bytecode in the JVM. But we may find we can't get the result, the correct result. That is because this runtime error occurs in the code. So the runtime error is not easy to find. And how to find this error? The tool, for example, the NetBeans, will give us the debugging tool set for us. We can make a breakpoint inside of a code. We will execute each statement one by one and try to find wait statement called this runtime error, but it's a very time-consuming work. Maybe a simple error, a simple runtime error will cost us 1 hour or 2 hours, even a week to find them and correct them. So we don't want to get this runtime error, but compile time error, it's not so difficult. So we welcome the compile time error, but we don't want to get the runtime error. And inside Java, it provides us a tool to convert some kind of runtime error to the compile time error. This tool named as generics. So let's get into it. What is the generics? The generics is some kind of type that it defines type, and when we use it, we can pass parameter to this type and customize this type. So some kind of runtime error, if it there, it will be converted to the compile time error. Let's check out this example. Now we have a code, write a class named box. And inside box, we define a object. We declare object, and we make two methods to operate on this object. The first one is set, another one is get. Use set method, we can put the object into this box, and use get method, we use the return, so we got this object from this box. So we define a box. Inside the box, we put object inside it, and we can get an object from it. That is a simple class we have defined. And this class is, we write it without generics. It's a regular class. And after we get this class, and then we will create an object based on this code, because we have class code. So we use new method to get the object of this box. So for example, we give the B, this reference variable, to access objects, this box. Now we get a box, and we use set and get method. We use set method, we put object in this box. For example, we create an integer, a numeric number. We get this integer object, and we use set method, we put it into a box. No problem. And then we want to get this integer from the box. So we use get method, b.get. We use this qualified name. So we use get method, we get object from the box. It's an integer, but as we define in this class, the get method, the return type is object. So we get the object type. But as we know, this object is the integer. So we use a cast. This is cast. Inside the parentheses, we put the integer as a cast. So it will convert the object to the destination type. The target type is integer. So we get the result as an integer. We got this integer that we have put it into the box before. No problem. These two statements are correct. Let's see another example. Now, the same box. I want to put a string object into it, so we create a new object, a string object, hello world, new string, got hello world object, and put it into the box. But when we get it out, I forget what type of object that I put into a box before. Why? In this example, you can see that these two statements close each other. There's the first statement and then the second statement. But actually, in a real situation, this statement may be on the first page of your code. We have code generally in the future. The code is not so short; it's long. So maybe this code we will use 100 pages in the editor. We have a very long code, and this statement is on the first page. But this statement is not on the same page. For example, it's on the 51 page. So the 51st page, the first page, and for example, this is on the first page, and the second one is get method is on, for example, the 50th page. So when we working on the 50th page, maybe we already forget what kind of object I put into a box before. Maybe I think, oh, what I put into a box is an integer. It's not a string. Because these two statements is not close to each other. They are separated each other on the different pages. So because I can't remember clear which kind of object I have put into a box. So I write this statement. I think what I put into a box is an integer. I think it's an integer. So I use this statement to get the object from the box. It's wrong. Because actually, the object I have put into the box before is not an integer. It is a string. It's my mistake. But because it's mistake, we have the error. But this type of error cannot be found during the comparing time. The comparer cannot find this error when it compare our code. So there's no compare time error. But when we run the code, when we executed the code, this statement, the error comes out. That is runtime error. So it's a runtime error, and we can only find it when we run the code. So when we run the code, we get the error, we may get back to my code and find which statement caused this error. Maybe it's a difficult task for us, as I referred before. So that is the box, this class, we write it without generics. But if we use the generics, we will write the code again. Now we add the generics. The generics is type. So we use a type. For example, T. We use T. We put a T into the class. So this is T, and it's T, and it's T, and it's T. That is in the first code, all this type is object, but the second code we use T to replace the object. That means now the box is customized for the T type. It's not for object. Object for everything, but we do not everything. We only customize it as T type. The other box is customized for T type. We only put the T type, the class, into the box. And when we get something from the box, it must be the T type. Because this box is only used for T type. It's customized for the T type. So we use the generics T to define this new box class. And then now we will create a new box because we have used the generics. So when we create the object for the box, we should write the statement is now we use the integer to replace the t, because the t, now the t stands for the integer. If you want to get a box customized for string, so you use string here. So this box is customized for string. So we use some actual type to replace this t. So we got a box customized for me. Now this box is customized for integer. So we put something into it, it must be integer. So we get a new integer object and put it into the box, no problem. And we got it from the box, it must be integer. So at this time, we do not need to use this cast, because it must be an integer, so we don't use the cast operation again. And let's see that this the same situation. Now, for example, we put a string into this box. We will try to do it, but we can't do it because at this time, this box is customized for string. No, it's customized for integer. If we put other kind of type of object, string or other kind of type object, it is not allowed, because this box is only worked for integer. Now you want to put the string in the box, it's illegal. See, it's not allowed. So it will give me an error, and this error can be found by comparison. So it's a compare time error, not a runtime error. So it's easy for us to find this error and correct it. That is the generics means. So the generics can convert the runtime error caused by the type, compare this kind of runtime error to the compare time error. So that is really helpful for us. I'll give you example in NetBeans. For example, I will write a code in the NetBeans. For example, now I define a box. In this box is we do not use generics, and we define another class, box test, and we new the box and we put a string into it, and we get it as just integer. So it must be an error, but it's not compare time error. So if we compare the code of box text, I will compare the code, compare file. Now let's see what comes out. Successful. It's no compare time error. NetBeans cannot find the error during the comparing time. But when we run the code in the runtime, this error comes out. It tells me that the string cannot be cast to the integer. There's two types, it doesn't match with each other. So this is runtime error. If we do not use the generics, this error caused by the type only comes out during runtime. But if we write a new code, now we use generics. We define new box and Z box, and use a T stands for to replace the object, and in the box test, now we customize this box object as work for the integer. So we use integer to replace the T. Now we get a new box, and if we want to put object that is not the type of integer. For example, it's a string. We want to put a string into a box. It's not allowed. It must be an arrow, and this arrow is compare time arrow. When we try to compare my code, and the compare will find this arrow, and it tells us, well, this is arrow, and it's because we cannot convert the string to the integer. So this compare time arrow, we simply it give us compare time, and in that means the compare time is just in time, so it gives it a symbol like a bar, like the red dot on it. So it indicates the 9. This statement have a compare time arrow. It's really easy for us to find it. So we find it arrow, and you know, oh no, we put the string to a box. Actually, this box is not for string; it's for integer. So we simply change it to our put integer into it. So when we compare again, there are no compare time arrow. So this is generics. We use the generics to help us to compare, to convert some kind of compare time, runtime arrow to compare time arrow. But the generic cannot compare all the runtime arrow to the compare time arrow. Only some kind of runtime arrow which caused by the type. So this generics. And now we move on to the next topic about exception. Exception is about error. The definition is exception is an event that occurs during the execution of a program that disrupts the normal flow of instructions. That means we have a code, we write a code, and generally the code will execute it, no problem. Normally, it gives us correct result, but sometimes some events comes up, and this event cause our code cannot execute normally. It will disrupt our execution. That is the exception. Okay. Let me give you a diagram for it. Both arrows, the compare time arrows, as I said before, the compare time arrows caused by because some code is not breaking the grammar rules, so you got this compare time arrow, and the compare time arrow can be defined by the compiler, so it's easy for us to find them and correct them. And but runtime arrow is not so easy for us. And about a runtime arrow, there's two kinds of runtime arrow. The first one is fatal arrows. In fatal arrows, that means the JVM crashed. For example, if the code, because we will use memory instead of code to create object, we should put object inside the memory. For example, for some reason, the memory is not enough for us to use to create new object. The memory is full, so we do not have new room to create a new object inside the memory. So the JVM is crashed. So this is a fatal errors. We cannot repair this type of errors. It's a disaster sometimes if we're running an actual system. This fatal error, and most of errors, runtime errors, is not the fatal errors. They're mute errors. For example, there's two kind of this mute errors. The first type is and we call that the runtime errors. The runtime errors, as another kind of, is a non-runtime errors. We will talk about it in the next section about the different kind of runtime errors, and most time that occurs in our code, including the runtime errors and the non-runtime errors. We only defined one of them as these errors that can be handled or deal with inside our code. I will talk about in the next section about the detailed information for this kind of errors. So now we will talk about the exception. In Java, it provides us a structure for describe this exception handling. That is, we have in grammar we have three blocks: try block, catch blocks, and finding blocks. We have three blocks, and let's give an example. Now we have two statements: start forced and what learn. It's our task. Our task have two steps. The first step is start forced. The next step is water known. As you know, well, start forced, then the water comes out from the faucet, then we have the water, so we can what known is two steps for us. But sometimes we have some kind of problems. For example, when we start the faucet, no water comes out, the water is running out because the water supply, some kind of, it's out of work. We do not have water. So we start faucet, but no water for us. So this statement, we got problems. We got error. So we cannot do the next step. So we cannot what load. So it is exception. This is exception. And when we execute the next statement, what load, for example, now we have water. We start faucet, the water comes out, and we have water, so we will what load. But before we what load, we notice that the load is wet because yesterday it's rain, and so the load is wet, so we don't need water again. So the what load, this task, we cannot execute it normally. It's accepted. So we have exception that will disrupt our normal execution of this task. Some errors may come from the start faucet, some we caused by the what load. So we put this statement, the two statements, into the try block. So into a try block, if this task may have some errors inside it, may have exceptions inside it, we should put it into the try block. So the try block, we have two statements put into it. And then we write the catch block for them. The catch block is for the different kind of exception that occurs in this task. For example, we have start faucet exception, we have what load exception. So we write the catch. Inside the catch parameters, you put the correct type for this kind of exception. Exception type is start faucet exception. And what load, we write the what load exception. And we mean it the catch, we mean this as exception handler. And inside the block, we write the actual code for it. That, for example, if this we start faucet, there's no water comes out, then inside the code, we write the code for it that we will pop out. For example, if the software will pop out a dialog box and tell us, well, there's no water. So you can try 1 or 2 hours later to come back and see if there's water or not. If it's water, then you continue to what load. If it's not, please wait. So we'll get some information for the user to start faucet. So we'll write this code into a start faucet exception. So once this, we must notice this kind of exception is maybe happen, but maybe it's not happen. So we write this code only for get ready for it. If it happens, we have code. We have write the code that before we have write the code, this code is ready to this situation. If this situation happens, we have this code executed. We have so the user will get information for it. So they know what happened in your code. So it's very important for software and write code. It's very important that you should let the user of your code, your program, let customers know what happened in your code. You pop out a dialog box, tell them, oh, there's something wrong. Please wait. This network is really slow. You can't continue network, so try to a new connection. You must let them know something, know what happened. And if you do not write any code for it, the user do not know what happened. It may be it's not very so you can't execute next step, and we don't know how to do it. So exception handler is very important for us to let the user know what happened and maybe do something to recover this error. Okay? And the workload is the same. For example, if they found that this loan is wet, and so they pop out the dialog box, tells the user, oh, now this water is already being watered, so you don't need the water again. So tell the user what happened in the code during this execution, what happened. So it's really important for make a code become a really stable code. It's very important. That is this event that is we name it as exception handler. We write the code into a box. And the next block is funny block. The funny block that is, for example, write something into the funny block. This statement is important because it will do some work that at the end step. For example, now we put the stop faucet. The funny block is work like this. Well, if the stop faucet and work alone, these two statements, no problem, no error comes out. So when we execute the finish stop faucet work alone, and the control comes into the funny block and execute stop faucet. This is the one of the situation. No error comes out. Another situation is something wrong. Some error comes out. For example, stop faucet. There's no water comes out. So there's a stop faucet exception. So execute the stop faucet. There's stop faucet exception. So we have already write the catch block for this kind of exception, stop faucet exception. So it will execute the code at the right into the catch block. So execute the code, tells the user the information about it, or do some recover work. And once finish the code inside the block, and the control will get into the funny block. So no matter it has arrow or do not have arrow, the funny block always inside the code, all the code inside the funny block always be executed. The stop faucet, because it's very important. Stop faucet, workload, the final step, you should stop faucet. It's very important. And if this is wrong, for example, you start faucet, no water, and you come to the funny block, you stop faucet. For example, if it's no water, the current time, no water, but 1 hour after, 1 hour later, the water comes out, but you have not stopped the forces, so it must cause some disaster, the flooding your home, right? So you should put the stop forces into a finite block. So the finite block, we put the finite block, that is the code will be we provided cleanup state or the method or in closing, we name it cleanup code. Cleanup code. In the real situation, for example, we will use the internet. We will connect internet to get data from the server, and if there's error in the step, so in the finite block, we should write the code to close the connection to the internet. It's really important because this resource for connection is limited for the operating system. So we should put some cleanup code inside the finite block. So that is, we have three blocks: try, catch, and finite. Inside the try block, we put our statement that may have exceptions. We put this code inside try block. And the catch block is based on the exception. We have two exceptions, so write two try catch block. We have three, we write three catch block based on the numbers of exception and then the type of exception. And we have put the finite block, and we will write some cleanup code into the finite block. That is the structure, the grammar structure for the exception. And then we will get into the next step. That is how the exception handler work. We have four concept words. That is exception object, throwing exception, exception handler, and catch exception. That is, for example, now we have the same code. We start force at what alone. For example, now we execute the what alone statement. At this statement, we have an exception. For example, the loan has already one quarter, so we have the exception. So the what alone, this statement will throw in an object. This object, the type of object is exception. We limit the exception object. This exception object will be catched by the JVM. So JVM knows that exception comes out, the object comes out. Then the next step, he will check, is there any catch block written for this type of exception? So they check the catch block list one by one till he finds the correct type for this exception. For fun, what exception find it, so we'll execute the code inside this block. So we name it catch exception, and the code write into the catch exception, and the catch exception we give the name as exception handlers. That is the four concepts. In the runtime, have a break. Now we come back to our class and we'll talk about this structure for the exception. That is, we have this grammar structure that is static structure. We have three blocks: try and catch and funny. And now the runtime, what is work? The working void that the try block has statement, this statement is queued. And if there's exception, now the exception may occur, may not. If there's exception, that was throwing exception. And this exception is object. And JVM got this object, and then it will try to find the matched exception handler. It look up the catch list, look up the type of the exception type. It try to find the matched exception handler. So if we find it, for example, we find it waterlow exception, then it will execute the code I have written in the block before. So it's an exception handler. But if there's no exception, so this to statement, finish statement, finish it, then it get into the final block. So we execute the start faucet. And if there's exception, once we finish the exception handler, the code inside it, and finally, we still get into the final block. So the start faucet is a cleanup code. It will be executed no matter there's exception or not. They should be executed, start faucet for our code. So this cleanup code in final block. Now we talk about this exception object. As we know, these arrows, exception is a kind of arrow. We have this diagram before. We'll give this diagram view. Yeah. This arrow, runtime arrow, we have the fader arrows. So the fader arrows, as we talk about it, it's a serious problem. For example, the memory leak. Not enough memory, so the JVM crash. It's a fatal error. but most of the runtime errors are not fatal errors. They should be mild errors. So the exception is one kind of these mild errors. So we talk about mild errors. We have three kind of mild errors here, and we will give you detailed information for it. We have three kinds of exception. The first one is non-runtime exception. The second one is runtime, and the final one, the last one, is the runtime exception. We have three kind of exceptions. The first type, non-runtime exception. What is the non-runtime exception? That is this exception that occurred in the code outside the JVM. So this exception is not inside the JVM, it's out of the JVM. For example, we try to get some data from a file. The file is out of JVM. It's managed by our operating system. We try to read some data from a file. But if we try to find a file, but the file is not existed in the file system. We don't have this file in the system, so there is an exception. We name it non-runtime exception. Actually, it's just the file not found exception, because it's the file that we wanted, it do not exist on the system. So we have this exception, non-runtime exception. It's a mild error. It's not a fatal error. It do not cause a JVM crash. Do not. But because this error, your code cannot execute to the next step. So this mild error. So for this kind of exception, we should write code, write exception handler for it. For example, if you find this file inside the system, if you have the software, if you graphic user interface, you should pop out a dialog box to tell the user that the name you provide. You want to try to find a file, you give the name of the file, but this file do not exist on the system. Please double check your name, the name of file. Maybe you give a wrong name, so you give a new name and then try it again. So it's a code we write into the exception handler, and it may recover this error and make our code continue to the next step. So this is mild error, the non-time exception. Another name for it is checked exception. And the second type for the mild error is runtime error. The runtime error, that is, error is still outside the JVM, but it's different from the non-runtime exception. Runtime error is different from non-runtime exception. That is, this kind of exception we cannot recover. We don't know what caused it. For example, we try to find a file. This file does exist on the system. We have this file in the system. But when we read the file, we got some error because the operating system, because the hardware errors from this hard disk or something else, we cannot make this operation correctly. There's nothing. We got this runtime error not for this error is not existed. The file does exist on the system, but because the other kind of errors are caused by the system, by the hardware, we cannot read the file. So this is runtime error. So it's different from the non-runtime exception. We name it as runtime error. This kind of error, we do not need to write code for it because we don't know how to deal with it. It's caused by the system, not by the resource. Not by for example, the file do not exist on the system. It's not this kind of reason. It's caused by system, so we do not write code for it. It's a runtime error. And the next kind of error, we name it as runtime exception. This kind of runtime exception is different from the runtime error. That is, it is inside the JVM. It caused by the code itself. For example, we write a code. We have non-substance bound array. We define an array. Inside an array, for example, we define a character array with the names of the array is 10. So we can put 10 of characters into the array. But if we try to find the 11th element in the array, actually it does not exist in this array because this array only have 10 elements inside it. So at this time, this runtime error, we got a runtime exception. This is out of bound exception. And the next example is if I have declared object, we declare an object, we define an object, but we do not create it. For example, we give you examples. It's a typical example. We have defined a class. For example, we define a class A. We define a class A. There's class A. Maybe something. There's online students. We cannot see it clearly, so I should the runtime error. I will launch a whiteboard for it. The whiteboard. Where is the whiteboard? There's a whiteboard for it. Oh, that's not it. So I add a page after, for example. Add a page after. We put a black page. Now, for example, what is the runtime error? A runtime error, as we talked about it, the runtime exception. The runtime exception is that we got it inside the JVM. For example, we have defined a class. Give my pen, get a red color. Now I get a pen and something. Now we define a class A. For example, define class A, something inside there is it's class A. Now we have A. We declare a reference variable, declare name as A, and we use the keyword. We will get an object, and then, for example, inside A we have 8x. Now we can access the x. Okay, we assign a variable. It's no problem. It's correct because we have created the object, and then we can use the object to access the variables we have defined in the object x. No problem. But if we write the class and then the next step we write it as this, and then we use a.x, assign a variable. It must be error. Why? Because we miss something. We do not have this step. We do not use new keyword to create an object. So we only declare a variable or a reference variable A, but we do not have the object. Actually, we don't have the object. So if we try to access object, we got a runtime exception. That is null point exception. We got it. That is runtime exception. So it's different from runtime error. The runtime error is an error that we got it outside the JVM. And this kind of error is caused by the system, not by the source, caused by the system. As we give example, there's a file, we read a file, and the file does exist on the system, but because the system error becomes a hardware error, we cannot read it correctly. So it's a runtime error. And the non-runtime exception is the exception that we got out of JVM, but it is recoverable. You can write code for it because it's caused by the source. We try to read a file, but the file does not exist on this system. So we got the exception. So the non-runtime exception. So these three kind of exception, the non-runtime exceptions, runtime errors, runtime exception, they are all mild errors. We all call them exceptions, but only the first type, non-runtime exceptions, we must write the exception handler to deal with it. But the rest two exceptions, runtime error and runtime exception, we do not need to write exception handler for them. The runtime error we cannot recover because it's caused by the error comes from the system. We cannot do it. Maybe the next time it disappears. I cannot deal with it because I don't know how to do it. It's caused by system. And the runtime exception, it's the same. We do not need to deal with it because this exception is inside the JVM. It's caused by my code. So if we got the null point exception, what we should do is go back to the code and find if there's something like this. We define a variable, a reference variable, but we do not create object, assign this object address to this reference variable. That we get this exception, null point exception. It's caused by our code. Especially if you are newbie for Java programming, null point exception, that's the frequently you got it, this exception in your code. Null point exception, because sometimes you forget to create an object and use it directly, so you got this null point exception. So go back to the code and find the code and we modify the code and that is. And this kind of exception has another name as checked exception. So for the checked exceptions, what we should do? We have to do something for the checked exception. For the non-runtime exception, we must write code for it. We have two methods to deal with it. The first one is we call it a catch. Another one is specify. The catch is that we write exception handler that can deal with this exception that we name as catch. And another method to deal with this exception is if I cannot deal with it at this time, we have no idea to deal with it. How we should do? We must write something for it. So now I will write the code to throw the exception out of the code. That will mean the specify. So we have two choices. We must get one from it. You can't ignore them. You must select one of this method, one of the two methods, catch or specify. If you catch exception, you must write the correct exception handler to deal with exception. If you choose specify, you must write through clause to throw out exception out of this out of your block, and throw exception out of the block to your father, because we will give example later, and throw it out to code block with the specify. I'll give example. Now we have an X method. With the X method inside it, we have a Y method. So the X method will invoke Y method. So X method is the father method of Y method because it invoke one method inside its block. And now let's see that the Y method will throw a non-runtime exception. The type is Z. So the Z exception will be thrown from the Y method. So inside X method, now we have exception Z. What we should do? We must choose one of the two methods, catch it or specify it. If we choose the first one, we want to catch the exception. What we should do? That inside the X method, we must write the exception handler. That is, we should put the Y method because the Y method, this statement, we have the exception in this statement. So we put Y method statement into a try block. And then we write the exception handler to catch the Z exception. And inside the block, we write the code to deal with it. So the catch Z exception is the type exception. The E is the reference variable. And inside it, we write the code for deal with this Z exception. That is the catch exception. So inside X method, there's a Y method, and the Y method throws exception, and we choose catch exception. So we put the Y method into the try block and write the exception handler for it. So if the Y method threw out the exception, and the exception will be catched inside Y method. So problem I have deal with it. This is first method, catch exception. And the second method, second way to deal with this exception, that we do not deal with this Z exception inside X method. We only want to do is throw it out. So we write the specify exception. That is, inside X method, now we have Y method. The Y method throw out the Z exception, but we do not need to put it into a try block and write exception handlers for it, because now the X method do not want to deal with this exception, only throw it out. So we write the throws clause, throws Z exception after this parenthesis as argument with throws exception and throw it out. So this exception thrown by Y method to the X method, but X method inside X method we do not want to deal with this. So what we should do? We can choose to throw it out. Continually throw it out. So throw the exception. To who? To the father of the X method. For example, there's another method that inside the method it invokes X method. So it should deal with this Z exception. That is specified. The two way, we must choose one from it. If there's a checked exception, we must do it. If we do not do it, the compare will give an error. Compare time error. Okay. I will give example in the NetBeans later. And now how we through exception. If we write a statement, how we through exception. Now we will give you example. Now we can use the through. Use this through as a keyword to through object. For example, in chapter 5, I have give you example stack. So the pop and a push the operation of the stack. For example, the pop, this operation, we will get items out of the stack. So now what we should do to do the pop operation, the first step, we will check there's a element inside the stack or not. So we use a size. If the size of the object as a stack is 0, that means no items exist in the stack. So we should throw exception. Now we define exception, the new empty stack exception. We use the through use the statement to throw out exception. We use this statement, and then if there's no element existing in that stack, so we can pop it out. So if there is no element inside the stack, we throw a new exception, stack exception. We use a through. Notice that have a throughs. That's different. The through new exception is if you write the statement, and this statement will through exception object. You use the through, use this keyword. But throughs it's not for a statement, it's for the method. If the method, inside the method, there is an exception. If the method do not want to deal with this exception inside it, if it decides to deal with it, it should put this statement into try box and write candidate for it. But if do not decide to deal with it, simply it throws this kind of exception out of the method. So use the throws exception, empty stack exception, throw it out. Through empty stack exception. So it's different. One is throws is worked for the method, and through is for the statement. It's different. Let me give you example. Give you example for it, and you can understand it. Close the window. Now I define a class, named my class, and here's a method. Inside the method would be have a y method. The x method will invoke y method, and the y method will throw a z exception. So this method will throw z exception. And what is the exception comes out? It comes from inside this y method. So use a through new z exception. We use this statement to throw the exception object. And inside the y method we have exception, but y method do not deal with this exception. So simply it throws it out. So throws the exception. What is the exception come from? We can define it. In the future, if you want to define the current exception, you must have exception as a superclass. So we have the superclass exception and derive a subclass Z exception. So Z exception is a subclass of Z exception, and we write the construct for it. And the constructor is to give the name of the exception. We give the name as exception, so use super message and to invoke constructor of the exception. That is give the information for the exception. So the exception. Now we have the Z exception. It's a subclass. It's a subclass exception, and then in the my class, I will use it to define my class. Use Z exception. Now got the exception object inside the Y method, and because the Y method inside the Y method do not want to deal with this exception, so simply throw it out. So through the exception. Now I know that Y method threw out Z exception, and this exception threw it to X method. So the X method now he have to give a decision. Two choice, get one. Catch it or specify. You must make a decision get one of the method, catch it, or just throw it out, specify. So if we do not do anything, we simply put it here, and the compiler will find that will tell you you have to do something for it, because the while method now there's exception comes out from while method inside an X method. So you should write something for it. You should make decision. You should get one of the two methods. You must do it. If you do not do anything, there's a compile time error, and your code cannot compare successfully. So you cannot get to execute code. It's important. So what we should do, if we choose the first method, choose the catch. So we should put while method into a block, try block. And then we write exception handler for it, catch Z exception, and we write something. For example, here we just print out something, print out E, that is information in the exception object to string to print it out. So that is we catch the Z exception inside X method. So if we do this, and this we will compare the code correctly. This is first method. And another method is if we do not want to write exception handler inside the X method, simply we throw it out. So we write throws a Z exception uses clause throws Z exception, throw it out. But the X method threw it out, and with the target is through. We will look at the code that it's the target through that. Now we create an object of this class, and we invoke X method. Now the X method just threw the Z exception out to the main method. So because the main method invoked X method, so the exception object do not disappear. It existed till you have dealt with it. If you haven't dealt with it, it still exists here. It do not disappear. So now simply it threw out to your invocator, that is main method. So main method have to do something. It's the same, catch or specify. One from the two way. You have to choose one. So if you do not do anything, yes, it's error. So you have to do something here. So maybe you follow the same. You choose the first way, that is, you put X method into try block and write the exception handler for it. This is the first way to deal with it, as a catch the Z exception in the main method and deal with it. Once you deal with it, this exception object disappears. But if you do not deal with it, it still exists. So the one way is to deal with it inside the method. So we put it in the try block and write the exception handler for it, just like this. But another way is, the second way is we specify. Just specify that it's the main method inside it, X method throughout Z exception, but I don't want to deal with it, so simply I threw it out, throws Z exception out. So once we threw it out, so inside the main method we do not need to put it in a try block and write exception handler for it. But we should throw it out, through the Z exception out. But now, as we saying this event, this exception object is does not disappear. It is still here. You throw it out to the JVM. So the JVM, because the main method is invoked by is JVM. So JVM invocates a main method, so the Z exception will through to the JVM. And JVM is a destination, the final target. If you throw the exception to the JVM, do you need to write a try block to into JVM? You do not need to do it. The JVM, the only thing inside JVM that is, it will print out the whole stack, the core stack of this Z exception. For example, if we throw out the Z exception to JVM and run the code, and what will happen? And the JVM simply print out a stack that tell you the route of the exception object passed. So look at this list. The first step, the exception comes from the Y method. Yeah, the exception comes from Y method, and the Y method through the Z exception to the X method. So to the X method. Then the X method you through exception and throw it out to the main method. So to the main method, and the main method continuing to through the exception to the JVM. So the JVM got exception, but the JVM do nothing for it. Only print out the route of this exception, how it passed from this one method to another one to another one to the JVM. That is how we should deal with the exception in our code. Generally, we should use the first way to deal with exception. That is, we should put the statement into a try block and write the correct if exception handling for it. That is a regular way to deal with exception. In the future, we use a lot of API that provided by the Payform JVM. We use API, a lot of class in the JPI. The method in the class will throw out exception. For example, if we want to write something use the internet, so we use a method to connect with internet. And this method, when we execute it, it has exception. It must have exception. So you can get an exception object from it. What we should do? We should put this statement into a try block and write the exception handler for it. For example, if we cannot connect the internet correctly, and because this method will give us exception object, and so we should write a correct exception handler, and inside the handler we write code for it. That is in the program. Our program will pop out a dialog box and tell the user, oh, now the internet connection is not available at this time, and just wait several minutes or just to try another type of connection. We must tell user to do something to recover the error. That's it. So the first way is the general way that when we deal with exception, we should put it in the try block and write the exception handlers. But if you do not want to deal with this exception, you can choose a second way, throw it out. But throw it out do not mean the exception object disappear. It not disappear until it will be dealt with in some step. It's very important. That is for the exception handler method in this section. And we'll go back to okay. I'll have a short break. Okay. I'll have break. Now I will upload the slides in the DingTalk. Today class file from a folder. Yes, upload to the slide. The slide. Yes. Slide 7. To the 7. Oh yes. Okay. Should be well, yeah, here. Open. 7. 7. Okay. Open my miner. 7. 1, 2, 3, 4, 7. No, 7 is here. Got it. That's it. I'll continue call. Uh, the next section is talk about something about the advantages of exceptions. Got it? If we have exceptions, what is benefit we get from this exception? We have three benefits and advantages we got from the exceptions. The first one, it will help us. Exception will help us to separating error handling code from regular code. Here's an example. Now we have this read file operation. We have 5 steps to read a file that is, suppose we have a file in the system that is open the file, determine the size, allocate the memory, and read the file to memory, and finally close the file. We have 5 steps to read the file. And generally there's no errors comes out that we finish this step, all the 5 steps, and we got the file correctly. But sometimes some errors occur, so maybe we can find the file because the name, we got the wrong name, we can't get the file from the system, and we can't decide the name, so we can't allocate enough memory inside the system, and sometimes a read file fails or the file cannot be closed at the final step. So this potential errors, that's exceptions. It may happen, it may not happen. So it's exceptions, and these exceptions connect with the resource outside the JVM. So it is the check exception that we must deal with it. So how to deal with them? If we have the exception handling structure, like in Java we have this, it's not a problem. But if we do not have this structure, for example, we have C language. We use the C language to write this file operation steps, 5 steps. But there's an exception. How we should do? We can do it. We use this decision-making branch. We use if, else statements, and we define error code. And we put these operations into this branch. And if this step is correct, no error code comes out. If this error, and give the correct error code in the step. So we use the error code to record the errors, and based on this decision-making branch. But we can do the job, but look at this code, it's mess. And the regular logic, regular statement, we have 5 steps for reading the file, but now it mixed up with this decision-making branches, with this error code, so it's not clear. If we use the exception handler, use try, catch, these blocks, and now this code is nice and short. So in try block, it's a regular statements, regular logic for a statement to have 5 steps: open file, determine size, open memory, read, and close. It's a regular logic for a code. And the catch, the handler, is for the error handling, exception handling. If there's some error, for example, the open file, we cannot find the file, so the catch, the file cannot open, so we have the recover code with defining the catch handling. So it's clear. It's very important that we got the benefit, use the exception that's separating the error handling code from regular code. So make our code clear, make our code become a nice and neat code. So it's important. And the second benefit, the advantage of the exception is propagating errors after call step. For example, now we have several methods. The first one, method 1 will call the method 2, and method 2 will call the invocate the method 3, and inside the method 3 we call the read file. And as we know, the read file will throw out exception. For example, there's no such file as your name. Get the name of the file, so it's throw out exception. And now this exception comes from read file. How to path through this method, because we want to deal with this exception not inside method 3, not inside method 2. We only want to deal with this exception inside method 1, inside first method. So that means you must propagating the arrows from 3 to 2 here to the first method, and at this location we will deal with exception. If we do not have this exception handler structure, we can do it with arrow code. Simply use a return type. Use a return value, and as we know, read file will return out us arrow code. And if this arrow and this arrow code will return by the method 3 to method 2, and the method 2 got this arrow code and continue to pass it to its invocator, because inside method 2 we don't want to deal with this arrow. So we passed, we return the arrow type, arrow code to the first method, method 1. And the method 1 here we will deal with these arrows. So we use this arrow code to pass the arrow information between the column. Because the first one method called the second one 3, and we use this arrow code with return value to pass, to propagate the exception. It's okay, but there's a problem. That once we use this mechanism, that means the return value, this important resource, we cannot use for other objects. So now we cannot use the return type, because the return type has already used by the arrow code. So it's sometimes the return value is very important, because as we know, as a method, we execute a method, want to get a result. How we get a result from the method? The return value is a very important way to get a result from a method. The method gives a result through this event value, from this return value. Another way is we should pass an object into this method, and this object this object we have defined the variable, and the variable will record the result. The result from this method, and take the result and out of this object. But it's complex. Then we use the return value. So the return value is a very important resource. But here we use it for the arrow code propagating. So this we cannot use again for other cases. But if we use this exception handler structure, simply we use through cross to propagating the exception object. So the read file is throughout exception, and the exception simply with the through exception to throw it to the invocator. The second method, method 2, and method 2 continues through the exception to the method 1, and in method 1 now in method 1 we choose catch the exception. We do not throw it again. So we put the call method 2 inside try block and write the exception handler to deal with the exception. We use this propagation. propagating this route is provided by JVM. So this return value, now use the return value. So return values, can use it as we want. Do not use it for the propagating the error code. The second benefits, and the third one, that is help us to grouping the different kind of error type. It's very important because as you know, if we do not have the exception, the only way we can deal with errors is we define the error code. The error code is a number. If we define error code, we have a defined number. For example, I'll give you an example. We will at the new page after a new page. No. Oh no, I have a blank sheet, and in this blank sheet and something. Yeah, I'll give example. Now I'll call grouping the error code. If the error code, and for example, I define error code as 1, 2, and 4. That is, we have the 3 digits, 1, 2, 4. And the first digits in the range is from 0 to 2. We have 3 kind of arrow, and then the 2 is 3 to 0 to 9 and 0 to 9. That means now we have 0 to 2, 3 kind of different type of arrows, and then we have 10 different kind of arrows, and then we have 10 different kind of arrows. We got a tree of the arrow code. It's not problem, but the problem is in the future. If we want to expand the tree, if we want to add a new type of arrow inside it, that is a really tough task to do it, because there's a tree, we want to add something to it. That means, for example, if we want to add a new type to the top category, we want to add it from 0 to 3. That means now we have 3 something. But if we want to add the further category to it, we want to add something to it, that means the format of the error code has been changed. Once the format of the error code changes, all this code inside your source code have to be found out and modified. It's a heavy task for us. Very boring task if we do it. Because we change the tree, change the format of the error code. So error code is not a reasonable way to define the errors. And the second reason is this error code is only a number. If you want to know something about this code, for example, 1, 2, 4 stands for what? I don't know. 1, 2, 4 stands for 1, 2. So we should have a table. We should define a table, and the table we will write a description for each code. For example, 1, 2, 4. This arrow is something, and 1, 2, 5. This arrow is something. We have to have a table to define it, to have the detailed information for each kind of error code. So that is, if we do not have this exception handler structure, we only have the error code. It's just some problem for us. But if we have the exception, because exceptions, the structure is we use is an object, so we use object. The object is a best way to organize different different kind of items, because this we have this tree, and this tree, and we can define different thing in it. For example, we have exception. This exception is all the exception with all is the father of all different exceptions, and it derive the different kind of exception. For example, the IO exceptions, other kind of exception, and IO exceptions, and because this object, the subclass is, for example, the file not found exception, not found exception. Cool. Exception. So, if you want to add something to it, simply we add a subclass. So add subclass, and old branches of the tree, we don't need to change it, and only we create new branches of the tree. So it's very important. It's different from this arrow code. The arrow code, we change the format, and the tree, all the branches have been changed. So your code have modified. But if you use exception, we don't need to do it. So it's very important. And another way is another important aspect of this exception is that we use object and it has a name. So have the name for this arrow. For example, we see the name IO exception that we know. This exception is related to the input output. And the file not found exception, and you know, oh, this exception is for the file. If we cannot find a file, there's a file not found exception. So we don't need a table to define the detailed information for each kind of exceptions. So that is why we use this exception, is grouping the different arrow types. But there's a problem for it. That is, when we use this a exception handler and the entrance, that is the parameters for the catch blocks. While we should use what kind of type we should use. We can use exception. We use IO exception with file not found exception. If there's a file not found exception, we have the exception, and we will use a file not found exception. The specific, this name is the correct name for the exception. It's no problem because it's a specific exception name. But we can still use this IO exception. We can use this IO exception to catch the file not found exception, because the IO exception, as we know, it's the superclass of file not found exception. So it's no problem. We use IO exception, we can catch the file not found exception. And we use the exception, it's a superclass of all the subclass, all the different kinds of exceptions. So no problem, it can catch exception. But the problem is, if you only use exception to catch all the exceptions, and in your code, you have to distinguish different kind of exceptions in your code. That's a complex job for you. So in general, we should this name we should use a specific name and make it as specific as possible. So if there's a file not found exception, we should use file not found exception in our code. We don't recommend you to use exception or it's superclass IO exception. For example, In the future, when we do coding work, if you use something about the method that will throw out exception, what we should do, I will give example. For example, if you want to write a code about the file read or something, and you can go to the documentation, and in the documentation, for example, I will show you how to do it, and document, and document, and document, the Linux, launch it. Go to document, the document, and APIs is documentations homepage. And as we know, this exception is the method, the API, that is method use the resource outside of JVM that may throw out exception. For example, I will give you something about file, the file reader, this is something like file. Sure, no. Some file exception. Let's give another example. Network, it's must have the socket. We create socket. So packages. Too many classes here. Net, Java net. Oh yeah, here. In Java net. Well, Java net. Java net here. And if we suck it, yes, extendable, suck it for throughout exceptions, suck it, shape. Well, for example, in the APIs, in the future, if we want to access internet, for example, internet is the source outside of JVM. So, for example, we have the API, it's a method named socket. We use socket to build a connection with the server or other machine on the internet with this method. And you can notice that the method will throw unknown host exception or IO exception. We throw two kind of exceptions: unknown host exception, IO exception, security exception, illegal argument exception. Well, so if you use this socket, use this method in your code, and you must put it into the try block, and put the socket into the try block and write the catch handler for it. So the catch handler, which kind of type of exception you should use, that you should use a specific name for the exception. For example, if there's a security exception, you should write security exception E in the catch handler, and inside the code is for this kind of exceptions. You do not use its exception, because the exception is not a specific name, although it can catch exception, catches security exception or illegal argument exception, but inside the handler code, you must write more code to distinguish which kind of exceptions comes out at this time. That is a difficult word, so we don't recommend all of you to use this name. So use this specific name in your handling code. It's very important. And in the future, once you use these APIs that access the source outside JVM, not of method will throw out exception. You can read the documentation for it. You can know what kind of exceptions it was thrown out, and then you can write your code, write the handler, and to catch this kind of specific exceptions and write code for it. That all this information inside the documentation. So read the documentation and you write the correct exception handler for this method. Okay. Also, the documentation. Well, documentation you can get it. Yes, documentation you can download it. All the documentation is one you get this Java development toolkit from the Oracle side, the Office side, Oracle side, and on the page you can see how to download documentation. It's a version, the correct version. I'll show you. I can see what I can access internet. What's the internet? For example, Oracle. We go to oracle.com. It's a little bit slowly. Net. Well, it's Oracle side, official side, and want to download something. Product, you can go there here and products. And Java software, a little bit slowly, and Java, and here, and you can see a lot of things. And now what we've done is solution, just watching over here. Download Java. And, now it's standard edition, it's 16, the version is 16. That's it's the JDK, the documentation download. The JDK download is as a toolkit, and the documentation download, and see the documentation, and download it, and the zip file, unzip it, and you have with this, and you got a folder, and use a browser to open this documentation. Right? It's very important because it's a menu. That is all these APIs you'll use in the future is inside this documentation. You learn how to use this documentation. That is it's quite simple because it's writing as a pages, and this is all these packages here, and it's on the right side this framework is the detailed information about it, and you check it and find suitable method and to find its definition, how to use it. It give you detailed information about the parameters, return value, and its exceptions if it has. Well, that's all about this exceptions. Go back to it. That's all for today's class. Now we talk about exceptions and how to deal with exceptions in your code. It's important because in the future, a lot of APIs are connected with this resource outside JVM will throw out exceptions. So you have to learn to how to put them into type blocks and write correct exception handler for it. Okay. That's for today. And I will make a roll call before we end of today's class. Okay. Where's my table? Well, reach the number. The 13th week, and the number I've got the 105, 105, 1, 2, 129, 129, 139.
Guys, pay attention.
130, 102, 0301. No. 03015. 15. And 02016. 16. Good. And 110. 10. And 112. There was all. And 122. Double 2. Thank you. And 125. Right. And 127. 27. And 7. Okay. 27. Yeah. You are learning 27? Oh. Because next person. 128. 28. No. No. Double 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6.
You didn't answer first.
Yeah, 7 students here. 1, 2, 3, 5, 4, 6, 7. 1, 2, 3, 4, 5. Yeah, all students here. Thank you. And that's all for today. And any questions, please leave messages on your box. Online students are the same. And if you have questions, leave message on your box. Thank you all, and see you. It means what? The slides are up, already uploaded this in talk today. This chapter. No. Let me see. Check it. No, we have upload. Okay, come back. I was sick. Stop.